Hello, my name is Matthew and I am part of Group 12. In this project, we were tasked with designing a device that can move weights using wind power. Today, I'm going to walk you through exactly how we did that.
Our problem statement was that we needed a low carbon emission device that quickly transported a max load of 17.9 pounds across a distance of 5 meters while adhering to the competition rules. The primary functions that we aimed for was that the device must move, it must hold weight, and it must stop once it reaches the landing zone. Some of the constraints we had was that the device had to fit within a 1 cubic meter starting box, we had a $25 budget, we could only use the tools that were given to us in the Fab Lab, and that all of our designs had to adhere to competition rules and regulations.
Jose is going to tell us about the research we did for this project.
So to better understand this problem and its background, we researched how wind power is used today to power watercraft. We found a lot of emerging technologies that were used to make water cargo transport much more efficient and environmentally friendly, such as wing sails, like those used in windsurfing. After all this research, we determined that the most practical way of utilizing wind power in our design would be to either implement a wing sail or to simply use a regular fabric sail so we can allocate more time to other parts of our design.
All right, now that we found out about some of the research that was done, let's go find out about some of the ideas that we came up with. All right, now we're going to talk to Elin, who's going to tell us about our ideation and selection process.
So we had two ways of ideation. It was brainstorming and the step back method. And from those two methods, we came up with the wind-powered airfoil cart, the weight-powered cart, the weight catcher, and the combined design. Wind-powered is in the name, uses wind. Weight-powered, it's in the name, uses power. It uses the weights that we were transporting to get to the finish line. The weight catcher uses the momentum of the weights that we need to carry down a ramp onto the cart, which will carry it to the finish line. And the weight-powered and wind-powered is a combined method using both elements of weight and wind-powered, and that carries us to the finish line. They were all very close. We used a weighted matrix, and we ended up with the combined.
Wow, isn't that just fascinating? Let's head to the Hardy Lab so we can do testing and show you everything we did. Now, we're here with Caleb, who's going to walk us through his final design.
So this is our final design that we came to. It includes a very tall potential energy source. This makes the weight fall down, providing spin to the axle, and once it comes to the bottom, it'll lock the axle, resulting in the vehicle coming to a complete stop. It also includes a very large sail. This gives the leaf blower more area to work on, providing more energy to our craft.
Are there any changes you had to make?
There were some changes we had to make. The biggest change was increasing the height of the tower. This gave more distance for the weight to fall and also additionally increased the size of the sail. Another big change was the front axle. We originally had two wheels, but it broke one time, and so we had to improvise and use a steel rod.
All right, now you know exactly how we went about our entire design process and how we got ready for competition day. Thank you for watching our video.